Hello everyone, my name is K. Rajesh. I am from CSCC section. Today's my topic is about error detection. Introduction. A condition when the receiver's information does not match with the sender's information. During transmission, digital signals suffer from noise that can introduce errors in the binary bits traveling from sender to receiver. That means a 0 bit may change to 1 or a 1 bit may change to 0. When the data is transmitted from the device to one device to another device, the system does not guarantee whether the data received by the device is identical to the data transmitted to another device. An error is a situation when the message received at the receiver's end is not identical to the message that is transmitted. Types of error. There are two types of errors: single bit error, burst error. Single bit error. The only one bit of a given bit unit is changed to one from 1 to 0 or from 0 to 1. Here is the image showing that uh, the the message sent and the message received. Here one 0 bit is converted to 1 bit. In this above figure, the message which is sent is corrupted as a single bit. That is 0 bit is changed to 1. Single bit error does not appear more likely in serial data transmission. For example, sender sends the data at a 10 Mbps. This means that the bit lasts only for once, and for a single bit error to occupy a noise must be more than once. Single bit error mainly occurs in parallel data transmission. For example, if 8 wires are used to send the 8 bits of a byte, if one of the wire is noisy, then the single bit is corrupted per byte. Burst error. The two or more bits are changed from 0 to 1 or 1 to 0 is known as burst errors. The burst error is determined from the first corrupted bit to the last corrupted bit. Here is the image showing the burst error. The duration of noise in burst error is more than the duration of the noise in the single bit. Burst error are mostly likely to occur in serial data transmission. The number of affected bits depends on the duration of the noise and data rate. Error detecting techniques. The most popular error detecting techniques are simple parity check, two-dimensional parity check, checksum, cyclic redundancy check. Single parity check. Single parity checking is a simple mechanism and is expensive to detect the error. In this technique, the redundant bit is also known as a parity bit, which is appeared at the end of the data unit, so that the number of ones becomes even. Therefore, the total number of transmitted bits would be 9 bits. If the number of ones bits is odd and the parity bits 1 is appeared, and if the number of ones bit is even, the parity bit 0 is appended at the end of the data unit. At the receiving end, the parity bit is calculated from the received data bits and compared with the received parity bits. This technique guarantees the total number of ones even, so it is known as even parity checking. Here, the sender sends 101101. It compute parity bit, and then next it check it creates a signal 1, and then it is transmitted to transmission media. Then the same code will be appeared to the receiver end and then compute parity bit. If the given code is given, it is rejected, else it is accepted data. Blocks of data from the source are subjected to a check bit or parity bit generated from where a parity of 1 is added to a block if it contains odd number of ones, and 0 is added if it contains even number of ones. This scheme making makes the total number of ones even. That is why it is called even parity checking. Drawbacks of single parity checking. It can only detect single bit errors, which are very rare. If two bits are interchanged, then it cannot detect the errors. In the image, if two errors are there, it cannot be detected. If there is only one bit, then it can be detected. Two-dimensional parity check. Performance can be improved by using two-dimensional parity check, which organizes the data in the form of a table. Parity check bits are computed for each row, which is equivalent to the single parity check. In two-dimensional parity check, a block of bits is divided into rows, and the redundant row of bits is added to the whole block. At the receiving end, the parity bits are compared with the parity bits computed from the received data. Here, in the image, the original data is given at the top and it is divided into parties and column parties. Drawbacks of 2D parity check. If two bits in one data unit are corrupted and two bits exactly the same position in another data unit are also corrupted, then 2D parity checker will not be able to detect the error. This technique cannot be used to detect the 4-bit error or more in some cases. Checksum. A checksum is an error detection technique based on the concept of redundancy. The checksum is basically divided into two parts: the checksum generator, the checksum checker. The checksum generator. A checksum is generated at the sending side. Generator subdivides the data into equal segments of n bits each, and all these segments are added together by using one's complement arithmetic. The sum is complemented and appended to the original data known as checksum field. The extended data is transmitted across the network. The sender follows the given steps. The block unit is divided into k sections and each of n bits. All the k sections are added together by using one's complement to get the sum. The sum is complemented and it becomes the checksum field. The original data and checksum field are sent across the network. Here is the image showing the sender and receiver. The sender sends the data to the package, and the package consists of data plus checksum. And the receiver receives the package, and it is of n bits. And if the result is zero, it keeps the data. If a result is not zero, it discards the data. Checksum checker. Checksum is verified at the receiving side. The receiver subdivides the incoming data into equal segments of n bits each, and all these segments are added together, and then this sum is complemented. If the complement of the sum is zero, then the data is accepted. Otherwise, data is rejected. The receiver follows the given steps. The block unit is divided into k sections and from each of n bits. All the k sections are added together by using one's complement algorithm to get the sum. The sum is complemented. If the result of the sum is zero, then the data is accepted. Otherwise, the data is discarded. Cyclic redundancy check, CRC. CRC is a redundancy error technique used to determine the error. Following are the steps used in CRC for error detection. In CRC technique, a string of n zeros is appended to the data unit, and this n numbers is less than the number of bits in a predetermined number known as division, which is n plus 1 bits. Secondly, the newly extended data is divided by a divisor using a process is known as binary division. The remainder generated from this division is known as CRC remainder. Thirdly, the CRC reminder replaces the appended zeros at the end of the original data. This newly generated unit is sent to the receiver. The receiver receives the data followed by the CRC reminder. The receiver will treat this whole unit as a single unit, and it is divided by the same divisor that will use it to find the CRC reminder. If the resultant of the division is 0, which means that it has no error and the data is accepted. If the resultant of the division is not 0, which means that the data consists of an error, therefore the data is discarded. Here is the image showing the data receiver and data sender. Thank you.